a WikiVidi documentaries production. Don't forget to like and subscribe. Enjoy. Ethanol. Ethanol, also called alcohol, ethyl alcohol, grain alcohol, and drinking alcohol, is a chemical compound, a simple alcohol with a chemical formula. Its formula can be also written as --, or minus, and is often abbreviated as EtOH. Ethanol is a volatile, flammable, colorless liquid with a slight characteristic odor. It is a psychoactive substance and is the principal type of alcohol found in alcoholic drinks. Ethanol is naturally produced by the fermentation of sugars by yeasts or via petrochemical processes, and is most commonly consumed as a popular recreational drug. It also has medical applications as an antiseptic and disinfectant. The compound is widely used as a chemical solvent, either for scientific chemical testing or in synthesis of other organic compounds, and is a vital substance used across many different kinds of manufacturing industries. Ethanol is also used as a clean-burning fuel source. Etymology. Ethanol is the systematic name defined by the International Union of Pure and Applied Chemistry for a compound consisting of alkyl group with 2 carbon atoms, having a single bond between them. Attached functional group -O group. The eth prefix and the qualifier ethyl in ethyl alcohol originally come from the name ethyl assigned in 1834 to the group minus by Justus Liebig. He coined the word from the German name ether of the compound -O-. According to the Oxford English Dictionary, ethyl is a contraction of the ancient Greek alpha theta O and the Greek word lambda eta. The name ethanol was coined as a result of a resolution that was adopted at the International Conference on Chemical Nomenclature that was held in April 1892 in Geneva, Switzerland. The term alcohol now refers to a wider class of substances in chemistry nomenclature, but in common parlance it remains the name of ethanol. The Oxford English Dictionary claims that it is a medieval loan from Arabic alcohol, a powdered ore of antimony used since antiquity as a cosmetic, and retained that meaning in Middle Latin. The use of alcohol for ethanol is modern, first recorded 1753, and by the later 17th century referred to any sublimated substance. Distilled spirit used for the spirit of wine. The systematic use in chemistry dates to 1850. Antiseptic. Ethanol is used in medical wipes and most commonly in antibacterial hand sanitizer gels as an antiseptic. Ethanol kills organisms by denaturing their proteins and dissolving their lipids, and is effective against most bacteria and fungi, and many viruses. However, ethanol is ineffective against bacterial spores. 70% ethanol is the most effective concentration, particularly because of osmotic pressure. Absolute ethanol may inactivate microbes without destroying them, because the alcohol is unable to fully permeate the microbe's membrane. Medicinal solvent. Ethanol, often in high concentrations, is used to dissolve many water-insoluble medications and related compounds. Liquid preparations of crack cocaine, pain medication, and mouthwashes may be dissolved in 1 to 25% concentrations of ethanol and may need to be avoided in individuals with adverse reactions to ethanol such as alcohol-induced respiratory reactions. Ethanol is present mainly as an antimicrobial preservative in over 700 liquid preparations of medicine including acetaminophen, iron supplements, ranitidine, furosemide, mannitol, phenobarbital, trimethoprim/sulfamethoxazole and over-the-counter cough medicine. Pharmacology. Ethyl alcohol is extensively metabolized by the liver, particularly via the enzyme CYP450. Ethyl alcohol increases the secretion of acids in the stomach. The metabolite acetaldehyde is responsible for much of the short-term and long-term effects of ethyl alcohol toxicity. Engine fuel. The largest single use of ethanol is as an engine fuel and fuel additive. Brazil in particular relies heavily upon the use of ethanol as an engine fuel, due in part to its role as the globe's leading producer of ethanol. Gasoline sold in Brazil contains at least 25% anhydrous ethanol. Hydrous ethanol can be used as fuel in more than 90% of new gasoline-fueled cars sold in the country. Brazilian ethanol is produced from sugarcane and noted for high carbon sequestration. The US and many other countries primarily use E10 and E85 ethanol/gasoline mixtures. Ethanol has been used as rocket fuel and is currently in lightweight rocket-powered racing aircraft. Australian law limits the use of pure ethanol from sugarcane waste to 10% in automobiles. Older cars should have the engine valves upgraded or replaced. According to an industry advocacy group, ethanol as a fuel reduces harmful tailpipe emissions of carbon monoxide, particulate matter, oxides of nitrogen, and other ozone-forming pollutants. Argonne National Laboratory analyzed greenhouse gas emissions of many different engine and fuel combinations, and found that biodiesel/petrodiesel blend showed a reduction of 8%. Conventional E85 ethanol blend a reduction of 17% and cellulosic ethanol 64%, compared with pure gasoline. Ethanol combustion in an internal combustion engine yields many of the products of incomplete combustion produced by gasoline and significantly larger amounts of formaldehyde and related species such as acetaldehyde. This leads to a significantly larger photochemical reactivity and more ground-level ozone. These data have been assembled into the Clean Fuels Report comparison of fuel emissions and show that ethanol exhaust generates 2.14 times as much ozone as gasoline exhaust. When this is added into the custom localized pollution index of the Clean Fuels Report, the local pollution of ethanol is rated 1.7. Where gasoline is 1.0 and higher numbers signify greater pollution. The California Air Resources Board formalized this issue in 2008 by recognizing control standards for formaldehydes as an emissions control group, much like the conventional NOx and reactive organic gases. World production of ethanol in 2006 was 51 GL, with 69% of the world's supply coming from Brazil and the United States. More than 20% of Brazilian cars are able to use 100% ethanol as fuel, which includes ethanol-only engines and flex-fuel engines. Flex-fuel engines in Brazil are able to work with all ethanol, all gasoline, or any mixture of both. In the US, flex-fuel vehicles can run on 0% to 85% ethanol since higher ethanol blends are not yet allowed or efficient. Brazil supports this population of ethanol-burning automobiles with large national infrastructure that produces ethanol from domestically grown sugarcane. Sugarcane not only has a greater concentration of sucrose than corn, but is also much easier to extract. The bagasse generated by the process is not wasted, but is used in power plants to produce electricity. In the United States, the ethanol fuel industry is based largely on corn. According to the Renewable Fuels Association, as of the 30th of October 2007, 131 grain ethanol biorefineries in the United States have the capacity to produce 7.0 E9 USCL of ethanol per year. An additional 72 construction projects underway can add 6.4 E9 USCL of new capacity in the next 18 months. Over time, it is believed that a material portion of the 150 E9 USCL per year market for gasoline will begin to be replaced with fuel ethanol. Sweet sorghum is another potential source of ethanol and is suitable for growing in dryland conditions. The International Crops Research Institute for the Semi-Arid Tropics is investigating the possibility of growing sorghum as a source of fuel, food, and animal feed in arid parts of Asia and Africa. Sweet sorghum has 1/3 the water requirement of sugarcane over the same time period. It also requires about 22% less water than corn. The world's first sweet sorghum ethanol distillery began commercial production in 2007 in Andhra Pradesh, India. Ethanol's high miscibility with water makes it unsuitable for shipping through modern pipelines like liquid hydrocarbons. Mechanics have seen increased cases of damage to small engines and attribute the damage to the increased water retention by ethanol in fuel. Rocket fuel. Ethanol was commonly used as fuel in early bipropellant rocket vehicles, in conjunction with an oxidizer such as liquid oxygen. The German V-2 rocket of World War II credited with beginning the space age, used ethanol as the main constituent of beestoff. Under such nomenclature, the ethanol was mixed with 25% of water to reduce the combustion chamber temperature. The V2's design team helped develop U.S. rockets following World War II, including the ethanol-fueled Redstone rocket which launched the first U.S. satellite. Alcohols fell into general disuse as more efficient rocket fuels were developed. Fuel cells. Commercial fuel cells operate on reformed natural gas, hydrogen or methanol. Ethanol is an attractive alternative due to its wide availability, low cost, high purity and low toxicity. There are a wide range of fuel cell concepts that have been trialed, including direct ethanol fuel cells, autothermal reforming systems and thermally integrated systems. The majority of work is being conducted at a research level, although there are a number of organizations at the beginning of commercialization of ethanol fuel cells. Solvent. Ethanol is miscible with water and is a good general-purpose solvent. It is found in paints, tinctures, markers, and personal care products such as mouthwashes, perfumes and deodorants. However, polysaccharides precipitate from aqueous solution in the presence of alcohol, and ethanol precipitation is used for this reason in the purification of DNA and RNA. Low-temperature liquid. Because of its low melting point and low toxicity, ethanol is sometimes used in laboratories as a cooling bath to keep vessels at temperatures below the freezing point of water. For the same reason, it is also used as the active fluid in alcohol thermometers. Chemical formula. Ethanol is a 2-carbon alcohol. Its molecular formula is CH3CH2O. An alternative notation is CH3-CH2-O, which indicates that the carbon of a methyl group is attached to the carbon of a methylene group, which is attached to the oxygen of a hydroxyl group. It is a constitutional isomer of dimethyl ether. Ethanol is sometimes abbreviated as EtOH, using the common organic chemistry notation of representing the ethyl group with Et. Physical properties. Ethanol is a volatile, colorless liquid that has a slight odor. It burns with a smokeless blue flame that is not always visible in normal light. The physical properties of ethanol stem primarily from the presence of its hydroxyl group and the shortness of its carbon chain. Ethanol's hydroxyl group is able to participate in hydrogen bonding, rendering it more viscous and less volatile than less polar organic compounds of similar molecular weight, such as propane. Ethanol is slightly more refractive than water, having a refractive index of 1.36242. The triple point for ethanol is at a pressure of. Solvent properties. Ethanol is a versatile solvent, miscible with water and with many organic solvents, including acetic acid, acetone, benzene, carbon tetrachloride, chloroform, diethyl ether, ethylene glycol, glycerol, nitromethane, pyridine, and toluene. It is also miscible with light aliphatic hydrocarbons, such as pentane and hexane, and with aliphatic chlorides such as trichloroethane and tetrachloroethylene. Ethanol's miscibility with water contrasts with the immiscibility of longer-chain alcohols, whose water miscibility decreases sharply as the number of carbons increases. The miscibility of ethanol with alkanes is limited to alkanes up to 1-decane. Mixtures with dodecane and higher alkanes show a miscibility gap below a certain temperature. The miscibility gap tends to get wider with higher alkanes and the temperature for complete miscibility increases. Ethanol-water mixtures have less volume than the sum of their individual components at the given fractions. Mixing equal volumes of ethanol and water results in only 1.92 volumes of mixture. Mixing ethanol and water is exothermic, with up to 777 J per mole being released at 298 K. Mixtures of ethanol and water form an azeotrope at about 89 mol% ethanol and 11 mol% water, or a mixture of 95.6% ethanol by mass at normal pressure, which boils at 351 K. This azeotropic composition is strongly temperature and pressure dependent and vanishes at temperatures below 303 K. Hydrogen bonding causes pure ethanol to be hygroscopic to the extent that it readily absorbs water from the air. The polar nature of the hydroxyl group causes ethanol to dissolve many ionic compounds, notably sodium and potassium hydroxides, magnesium chloride, calcium chloride, ammonium chloride, ammonium bromide, and sodium bromide. Sodium and potassium chlorides are slightly soluble in ethanol. Because the ethanol molecule also has a non-polar end, it will also dissolve non-polar substances, including most essential oils and numerous flavoring, coloring, and medicinal agents. The addition of even a few percent of ethanol to water sharply reduces the surface tension of water. This property partially explains the tears of wine phenomenon. When wine is swirled in a glass, ethanol evaporates quickly from the thin film of wine on the wall of the glass. As the wine's ethanol content decreases, its surface tension increases and the thin film beads up and runs down the glass in channels rather than as a smooth sheet. Flammability. An ethanol water solution that contains 40% alcohol by weight will catch fire if heated to about 26 degrees Celsius and if an ignition source is applied to it. This is called its flash point. The flash point of pure ethanol is 16.60 degrees Celsius, less than average room temperature. Dishes using burning alcohol for culinary effects are called flambés. Natural occurrence. Ethanol is a byproduct of the metabolic process of yeast. As such, ethanol will be present in any yeast habitat. Ethanol can commonly be found in overripe fruit. Ethanol produced by symbiotic yeast can be found in burnt palm blossoms. Although some animal species such as the pintail tree shrew exhibit ethanol-seeking behaviors, most show no interest or avoidance of food sources containing ethanol. Ethanol is also produced during the germination of many plants as a result of natural anaerobiosis. Ethanol has been detected in outer space, forming an icy coating around dust grains in interstellar clouds. Minute quantity amounts of endogenous ethanol and acetaldehyde were found in the exhaled breath of healthy volunteers. Autobrewery syndrome, also known as gut fermentation syndrome, is a rare medical condition in which intoxicating quantities of ethanol are produced through endogenous fermentation within the digestive system. Production. Ethanol is produced both as a petrochemical, through the hydration of ethylene, and, via biological processes, by fermenting sugars with yeast. Which process is more economical depends on prevailing prices of petroleum and grain feedstocks. In the 1970s, most industrial ethanol in the United States was made as a petrochemical, but in the 1980s the United States introduced subsidies for corn-based ethanol, and today it is almost all made from that source. Brought to you by WikiVidi documentaries. Would you like